So welcome back to the computer organization and programming class. So we're going to continue today on chapter 7. So we already covered quite a bit of chapter 1 to chapter 4, and then we moved right away to chapter 6, and that's when we learned about the if statements and the conditional processing. And today we're going to move into another topic, which is integer arithmetic. All right, so we're going to just look into the big picture. So this presentation is going to be, or this lecture is going to be into two different presentations. Today's presentation, which is I'm going to lead right after I finish recording it. And the other one is going to be on Wednesday. Okay. So I will create a discussion section. So in case if you have questions, you guys need to help each other. And if the time allows, I will jump there and help you as well. So I'm trying to learn how to teach online. This is my first experience. So if you see anything like it's not perfect or it's not how you expected it, it's on me. I'm just learning how to do the online teaching and learning. I'm very active. I like to be in the class. I like to be with my students, but this is what it is right now. We have to deal with it. Okay. So we're going to talk today about integer arithmetic. So there is a very interesting topic, which is shift and rotate. So you might think about right now, what is he talking about is what shift has to do with anything when it comes to into arithmetic. So we will see like we can do arithmetic with shift. All right, and we're going to look into the rotation as well. All right, so this is what we'll try to cover today. And in the next class, we're going to talk about multiplication and division. Hopefully we're going to finish it. If not, then we have to do it in the following class. All right, the extended addition and subtraction, if the time allows, I will go over it. Otherwise, you can refer to the book. But this is usually something like advanced addition and advanced subtractions. All right, so let's look into the shift and rotate instructions. So if you can see the board well, let me see if I can make this one a little bit better, maybe closer. Okay, hopefully this will be better than the last experience. So when we talk about shift, let's just imagine if you have a byte. Let's say 0, 0, 0, 1. This is 8, right, guys? You with me? So this is an 8. So we are talking about shifting. When we shift in this way, we are shifting to the left, right, and then, or we are shifting to the right. Okay, so we insert something from the right direction, or we insert something from the left. Okay, so we're going to see the effect on arithmetic. So we know integers, we know sign, we know unsigned, and these are all should be something straightforward, right? So we're going to see what happens if we do shifting. Let's just play with it a little bit. What happens if we insert a 0 right here? So if you insert the 0 right here, we know it's a byte. It cannot have 9 bits, right? So this bit must go away, right? If we lose that bit, then this bit will shift, right? So this 0 is going to come here, push this 0 here, this 0 here, this one here, this one here, this one here, this one here, and this is gone. Okay, so when we shift to the right direction, it seems that 8 moves into a 4. Let's see what happens when we shift to the right. So this is division, in fact, when we shift to the right. Okay, when we shift to the right, that means we insert 0 from the left. So that's going to shift it to the right. So let's say now we insert a 0 from the right and see what happened. Okay, so if we do this one, then we're going to have a 0 inserted. So the last 0 is going to be lost. In fact, there is nothing lost. We will see later. So if we can see, this 0 is going to come here, this one here, this one here, this one is going to be here, this one here, this one here, this one here, and this 0 is going to go somewhere, maybe to the carry flag. But look at the number right now. It's no longer 8. It's what now? It is 1, 2, 4, 8, and 16. So it seems that now we are doing multiplication, right? So we multiply. So when we shift to the left by inserting a 0 from the right side, shifting to the left, it will be as if we multiplied. Okay, but it has to be a multiple of 2, correct? If the multiplication is not a multiple of 2, then shift cannot do that type of multiplication. All right, so it has to be a multiple of 2. So we know the reason is because of the base, right? 2 to the power 0, 2 to the power 1, so binary system. All right, so this is the big picture. So shifting is very interesting. So let's move into the main idea right here and see what is shifting. Okay, so these are the type of instruction that we're gonna cover today. So it's gonna be mainly shift to the left, shift to the right, and we shift arithmetically to the right, and we shift arithmetically to the left. So we are talking about 2 types of shifts right here, okay? Shift that is arithmetic and shift that is logical. And we're gonna see the difference between both, all right? And then if the time allows, we're gonna go to the rotations and we will see how the rotation works. Okay, so the whole idea of the shift, as they say, it's the bit shifting. You just insert a bit from the right side, then it's gonna shift everything, and then the bit at the end is gonna be lost. All right, so you're gonna see, can we shift by 2 bits? Can we shift by 3 zeros, sorry, or 1 0 or 4? Yeah, you can do. If you insert 4 zeros, it's gonna push out these 4 zeros. Okay, so it depends on the direction and how many shifts you need. Okay, and sometimes you might zero out the value. So you're gonna look at it. So these are the operations provided by x86 in case if you wanna do shifting. All right, so we have logical versus arithmetic. So when it comes to the arithmetic cares about the sign. Because if we shift from the right to the left or the left to the right, we are playing with the sign of the value, right, guys? So when we do logical shift, we don't care about the sign. But when we do arithmetic, we care about it. All right, so the instruction used for both shift right and shift left, do you see it? So this is logical, either left or right. And this is shift, as you can see it there, arithmetic, okay? Sorry, either left or right, okay? So we have shift arithmetic and shift logical. Let's look at the whole idea. So it's there are 2 ways to shift an operands, right? So the logical, that is the main idea of the logical shift. So it's just gonna create a new position right here, and everything else is gonna be shift. So we don't really care about what is the sign. So you can see it right here, right, guys? So if you look at it right here, if you insert 0 from the left, that means you're shifting to the right, right? So when you shift to the right, we notice here, when we shift it to the right, 8 become 4. Okay, so 8 became 4, right? So it's shifting to the right is like a dividing by 2, right? Because 2, why dividing by 2? We just shift by 1, right, guys? Right, so if we shift by 1, so 2 to the power 1 is what? 2. So it's like we are dividing by 2. If we shift 1 to the left, right, by inserting 0 from the right, then we are shifting by 1. So then that's exactly like multiplying by what? 2. So 8 by 2, it's going to be 16, and that's what we got. It's 16. All right. So what if you want to insert 2 bits? Okay. What if you want to say, I want to shift by 2 bits? Okay. Then you are multiplying by 4, or you are dividing by 4. So the power right here is going to tell you the magnitude. Are you going to multiply by that value, or are you going to divide by that value? All right. But this is exactly what the whole idea is. You see, like this 0 is going to push everything. And the last bit that you're going to have right here for this example 1 is going to go to the carry flag. All right. For simple reasons. The reason why it goes to the carry flag, we are not very much interested in this right now. Okay. We are focusing mainly on this part. Hopefully you guys see the board better, because I find on the the video discussion, some of you felt like the board was not clear. So I'm trying to get very close to the board. Okay, so this is, you can also do the shift by arithmetic. So when you say shifting by arithmetic, we have to care about the bit, the most significant bit. What we care about, because the most significant bit right here, guys, is what? The most significant bit is the sign, right? So it matters when we shift where? When we shift to the right more than we shift to the left, as we will see, because when we shift to the right, that's going to actually affect the bits, but not vice versa. We're going to talk about this. So this is like when the shift arithmetically 1 bit to the right, it becomes this value. So maybe the value is going to change its sign, right, from positive to negative. We don't need that to happen, but we just need to pay attention. Like shifting arithmetically, it might affect the most significant bit, the sign. We don't care about this bit right here, right? The bit that we have right here. Okay, because this bit is not the sign bit. This is the least significant bit. We focus on the most significant bit. All right, so this is like the whole idea, like arithmetic and logical. So in the logical, we don't care, shift right or left. We don't care about the sign because it is unsigned number. It doesn't care about what the sign is. Just gonna say, if you shift here, if you're shifting to the right, then you're multiplying. If you're shifting to the left, then you're dividing, and we don't care much about the sign. But if we are doing arithmetic, the sign matter, whether the number is unsigned or signed matter. We're gonna play with a couple of examples. So right now, these are the real instructions. Okay, so we have shift instruction right here, and this shift instructions is gonna deal with the content and a register, right? Or a content in a memory. And you can rotate, or sorry, you can shift the values to the left. This is SAHL, this is an instruction. So this is SHL or SHR to the right. And then you have to provide the arguments 1 and the argument 2. So this is could be a register or memory, okay? And that is the destination. And then the source, if it's an immediate, it has to be an 8-bit. So that means you cannot do more than 2 to the power 8. Okay? If you want the destination, so this is could be immediate, or it could be a register. So either way, if it's a register, it must be CL. Okay, so that's again, register can contain the shift, the amount of shift that we want to make. Are we going to shift by 1 0 or by 2 0 or by 3 0? So how many times are we going to shift? We might shift it by 8. So that is, you're going to shift everything. All right, we're going to play with those, but is that clear in your mind? Okay, so we are doing arithmetic. Remember, the chapter is all about arithmetic, and we are learning instructions that they're going to do fast multiplication and fast division, by the way. Okay, because when you shift to the left, you are multiplying, and this is really quick. There is no vacations for the adders or multipliers. This is just going to happen at the CPU level. So that's why I want you to learn about it. And it's very important, of course, in your programming career or in your software engineering career anyway, because you might need to solve a problem in that way. All right, so let's look at this example right here. So the example right here, we want to shift to the left, and we have this value. We move the value to PL. So the value is what right here? Let's just, now we're doing shifting to the left. Okay, and in this case, we are shifting 8. So this is 8, and then this is F. Okay, so this is what we moved to BL. So this is the value in BL. So right after that, we can see it right here. We say shift BL by 1 to the left because it's a SHL. All right, try that one in your Visual Studio. So if we shift that by 1 to the left, right, we want to move this way. So we have to insert bit from the right side, right? So automatically the CPU is going to insert 0, but you need to understand that, right? So the computer is going to insert 0. So inserting 0 is going to push everything to go somewhere else, right? You with me, guys? And this is going to go to the carry flag. So the carry flag now is equal to 1. And the values right here, it's going to be what? This one. Do you see it? It's going to be here. This one, this one, this one, this 0, this 0, this 0. Do you see it now? So this is now my new value, right? Instead of this. And this is my new value instead of that. Okay? So if you look at the value right here, now you have a completely different value. So that's what happens when we shift to the left. Do you see it right here? So after you shift, the result right here, it's going to be 0, 1, 1, 1, 1, 1, 0, 0, 0, 0. These are the 3 zeros right here. And then the carry flag has a 1. Okay? So what happens if we want to shift by 2? Instead of saying shift to the left, BL by 1, we're going to say by 2. If you say by 2, then you have to insert 2 zeros, right, guys? So if you insert 2 zeros, you're going to lose the carry flag first is going to be 1. And then when we do the next shift, is going to be what? 0. So the updated value is going to be 0. You see what I'm talking about? So this is exactly what is it going to be. All right. It's going to be 0, and then it's going to be 1. All right. So that's exactly how the shift works, to the left and to the right. All right. So that's the carry flag when we do it multiple times. So that's what I talked about right now. So just imagine that we have the same value and we say shift by 2. So the instruction right here, shift to the left, PL by 2. Do you see it? Is that kind of close a little bit? I'm trying my best, okay? I already get my electronic whiteboard. That's why I'm late in uploading the slides, because I was playing with it. I tried to install it, but it took more than I expected. So I think hopefully I will get it done today. And starting the next class, I'm going to use the electronic whiteboard. All right. So right now, if we want to play with this example, you can play with the one right there. But if you want to play with this example, if we want to shift it twice, that means first we insert. Let's do it in 2 steps. The computer is going to do it really fast, but let's do it in 2 steps. If we insert the first 0, as we said, we're going to get, I will lose this one. So I will do it very fast. This is going to be the carry flag value. It's going to be 1. So I know I will be losing this, and I will insert 0. Then blindly, I just will insert this except for the most significant bit. So it's going to be 1, 1, 1, 1, 0, 0, 0. And then the carry flag is 1. And then since it's 2, the computer is going to insert another 0. Okay, so when we insert another 0, then this is going to be gone, right? So the carry flag now is going to be what? It's going to be 0. So now I will put everything here, right? Except for what? It's going to be, I'm sorry, I made a mistake. So we're going to insert the new 0. So that's going to push this 0 right here, right? So this all going to stay the same, except for this guy, right? For this bit. So this bit is going to be now the new value. The old value is going to be overwritten. So I would say this is the inserted 0. Then I would put 0, 1, 1, 1, 1, 0, 0. You see the new value? So if you say by 3 in here, then you need to insert 3 zeros. I can do it very fast. I would say 0, 0, 0, like the computer. And I know that I'll be losing this 3s. So the carry flag first is going to be, I'll be using these 3s. So the first time the carry flag is going to be 1, and then 0, and then 0. So I know these are going to be lost. So I will just kind of, I don't see them, and then I will insert this value. So it's going to be 1, 1, 1, 1, 0. So that's what happens if we say shift to the left, the content of PL by 3. So that's going to be the result. If you feel like this is a good approach, you can follow, you can use it, or you can come up with yours. So for me, I know I'm inserting 3 zeros. It's better in the beginning to do it 1 step at a time. So that way you will feel what it takes to do the shifting, okay? And that's exactly how the computer does it, or how the CPU does it, but it happens at a very fast speed, all right? But for us, you can put the 3 zeros and you lose the last 3 value, but make sure this is going to be the value you should report for the carry flag, because the carry flag is going to be 1, and then the second time 0, and then the third time is going to be 0. Okay. So this is what this slide is all about. Just what happens to the carry flag if we are doing multiple shifts. Okay. And this is fast multiplication. All right. So the whole idea of the multiplication, guys, if you got this point, it's going to make your life way easier. Okay, so the idea right here is you need to know the relationship between shifting, the number of times you shift, and the multiplication. If you shift something by 1, that is 2 to the power 1, 2, then you are multiplying by 2. If you shift something by 2 times, that means 2 to the power 2, you are multiplying by 4 if you are shifting to the left. If you are shifting by 3, then 2 to the power 3, then you are multiplying by 8. If you're shifting by 4, then you are multiplying by what? 16, and so on and so forth. And the same applies to what? To division. So if you're shifting to the right, then you are dividing by 2. If you just shift by 1 bit, so let's say, by one shift. So you're going to say shift to the left, AL1. So that is 1, the number of shifts. This is the number of shifts, okay? So if you say 1, that means you're multiplying by 2, okay? So if I said, imagine that we have 4 in AL. If we have 4 in AL, I know that the result should be what? 8, because we're going to shift it to the to the left, all right, by 1. So if it's 4, it's going to be 8. Just imagine if it is going to be 0, 0, 1, 0, 0, 0, 0, 0. Okay, do you see it here? So that's 4, right? If AL is equal to 4 and we shifted once, if we shifted once to the left, then we are multiplying by what? 2. So we assume that this value should be 8, and it should, because when we insert the 0, then this is going to come here, this is going to come here, this is going to come here, this is here, this is here, this is here, this is here, and this is going to go to the carry flag. So the carry flag is 0. Isn't that 8? Because this is 1, 2, 4, 8, right? So when you multiply to the left by 1, you are multiplying by 2. You shift it by 2 in here, then you're multiplying by 4. If you do this number and you say shift twice, then this is going to be 16, because you're going to shift the 1 here and there. And that makes sense, right, guys, without even writing this. So if I shift this here and then this here 2 times, when I shift it here, it's going to be what? This is 1, 2, 4, 8, right? And this is 16. So it was 4, and I shifted here, it's going to be what? 8. If I shift it there, it's going to be 16. So it depends on the number of the shifts that you're going to make. Okay, so this is what you see in this equation. So this is the multiple times. This is number 2. Okay, and here you're shifting it twice. Okay, so if you're shifting it twice, that means what? I'm multiplying by 4. Right? If I shifted once, like you see the example right here, then I'm multiplying by 2. So 2 by 5, the result should be 10, as you can see it here. And this is 5, and you inserted this 0. So you're going to shift this 0, this 1, and so on. And the last bit that you have right here is going to go to the carry flag. So now we're going to have the new value, which is 10. Okay? So if this is your value, if you move 5 and you actually going to shift it by 2, then I know I'm going to multiply by 4. So I'm expecting the result to be 20. You got the idea? Okay, so this is logical shift, left. And then now we're going to look at the logical shift to the right. It's exactly the same. But the only thing that we're going to learn, if we shift to the right, we're going to do division, right? And that is basically what this chapter is all about, which is integer arithmetic. Okay, guys? Trying to get this guy fixed. Okay, you go back a little bit. All right, guys. So let's now go to the shifting to the right. So now we want to shift to the right, then we have to insert 0 from the left. You see it? Hopefully I'm not confusing you, but just imagine you want to shift something to the right. If you are here and you want to shift it to the right, so you have to insert something from the left, right? From this left, so it's going to go to the right. All right, and then you know that the least significant bit right now, this is the least significant bit, is going to go to the carry flag. Okay, and the shift logically to the left, the most significant bit was the one that is being shifted or was moved to the carry flag. Okay, so this is exactly identical. So here you have 0D0. The reason we have this 0 is just because we know we cannot start a value with a hexadecimal. It's going to confuse the assembler. Right, guys? So if that is the case, then now we're going to have D0. Okay, so if this is my D0, I know this is bit manipulation, so I have to break it. So I know A is 10, B is 11, C is 12, and D is 13, right? So 13 means what? 13 means we have 8, right, guys? And we have 4, that's 12, and we have 1, that's 13. You with me? Okay, so this is exactly what the value is. That is the value that you see right here. Okay, and we want to shift it by 1 to the right. Okay, so we're going to shift this 1 time to the right. So we have to insert a 0 from here to shift it this way. Okay, so this is going to bring this one here, this one here, this 0 here, this one here, there's 0 here, there's 0 here, there's 0 here. This one is going to go to the carry flag. You see it? So this is going to be your new value. If you want to report it in terms of hexadecimal, this is going to be 8, and this is going to be what? 246, right? Okay, guys? So that used to be D0, now it's going to be 68, which is dividing by 2. If you divide this by 2, this is the value you're going to get. What happens if you divide not a multiple of 2 number? Okay? So you just like in Java, right? So when you divide this in Java, if you go to Java and you say 5 by 2, look at the result in Java. It's going to tell you 2, because it will assume that it is doing integer division. Okay, so in the integer division, the Java interpreter, it's not going to look at, it's going to just ignore the fraction, because this is integer. If you want this to be real, then just put this dot right here, I'm sorry, and then you're going to get 2.5. And the reason is because the CPU really needs to know whether the number is integer or real. If it's integer, it's going to ignore the fraction automatically. Okay? But we're going to capture the fraction when we move a little bit at a different level. I will talk about that if the time allows. Okay? So again, if you're doing multiple shift to the right, you need to worry about the carry flag, right? So if you do this twice, then this is the first carry flag, then the second carry flag. When is it? How many times do I need to shift to have the carry flag 1? So this is 1, 2, 3, 4. So I have to shift by 4. So this is 1, 2, 3, 4. So it means 5 times. So I have to shift by 5 to get this one here. So the first time I shift, it's going to go this, second, third, fourth, and fifth. So I can say if this is a PL, I can say shift to the right, BL by 5. Then I know if I ask you what the carry flag is, it's going to be 1, because this is what happens, right? This is going to be my first carry, and then it's going to be overwritten by this, and then overwritten by this, and then overwritten by this, and now it's going to be 1. Okay? Is that kind of clear? Okay. So this is the fast division. Okay? This is very fast division. Okay? So the fast division right here, if you have this 80 and you shift it by 1, right? So it's going to be what? It's going to be 40, because if we shift by 1, that means we are dividing by 2. Okay? Do you want me to remind you? Just keep that in mind. It's a little bit simple but confusing. So 2 to the power 1, 2 to the power 2, 2 to the power 3. At least get it to 2 to the power 3. So you know if you shift by 1, you are multiplying or dividing by 2. If you're shifting by 2, you are multiplying or dividing by 4. If you're shifting by 3, you are multiplying or dividing by 8. So here we said shift by 1. Then if I shift by 1, I know I'm dividing by 2. So if you want to look at it, this is what the 80 is, right? So if we shift it by 1 to the right, we're going to insert a 0. That's going to bring this one here, 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 here, and this is going to go to the carry flag. So if you look at this number now, it's 4. It was 8, now it's 4, because we moved this 1 in here. And we know, right? 1, 2, 4, 8, 16, 32, 64, 128. So this number is gonna, it's gonna go and become the 8, since this is a 2 hexadecimal number. So I'm not trying to confuse you. So this is gonna be 8, it's gonna be 40. So this is gonna be 40. And here, that is the 0, right? And this is going to be the 0. Okay. So this is what happens. So this 40 becomes, this number becomes 40. If you now shift twice 40, because you're already 40 now, and if you shift it twice, I know if I shift twice, do you see it here? Then I'm dividing by what? By 4. Then the result should be what? Should be 10. You got it? Kind of? Okay. So this is mainly the logical shift. So in the logical shift, we don't care about the most significant bit, because the sign means nothing right here. Okay, so right now we're gonna look at the shift arithmetic. So the most significant bit is very, very much important. But shifting to the right, I mean shifting to the left, it's gonna be identical. Okay, if we want to shift to the left, it's gonna be identical to the logical, but shifting to the right is going to be special. Let's just look at it now. Okay, so here we have the shift arithmetic to the left. So that is when we're going to have our on 0, the one in red right here. So if you do it is identical. So now we're going to shift to the left. So the most significant bit now is going to go to where? Is going to go to the carry flag. Okay, so so this is exactly what the basic idea is. Okay, so if we're shifting a binary, like the number you see right here, do you see the most significant bit is a 1? And if we shift it to the left by 1, it's going to become this value, right? So you might wonder what that value is, because you're just looking at zeros and ones, they make no sense. So if I were you, I would just go to this number and convert this number into a decimal and look at that number and then choose complemented it. So that way we're going to get what that number is in decimal. To complement that number, get it in decimal, and then you will know it. So when you shift it right there to the left, so the number still holding its sign, right? Sign was not very much affected. We'll show you a couple of examples, but right now I want you to focus on this. Okay, so this is what we did right now. So we shift arithmetically to the left. Okay, so shift arithmetically to the right is identical to shifting to where? To shift logically to the right. So if we want to shift to the right, it doesn't make any sense. Okay, so right here, when we say shift arithmetic to the right, so what we're going to do, we're going to perform the right arithmetic shift. All right, so we have to duplicate the sign. All right, so now when we do it to the right, it's exactly the same. It's identical to the shift to the right. The only difference right here, we have to look at the most significant bit and duplicate it. If it's 1, then we will shift by 1 to the right. Why? Because we don't want to change the sign. Just imagine if this is a number and you want to shift it to the right. If you want to shift this number to the right, right, guys? If you insert a 0, and if this is an arithmetic shift, you change the number from negative to positive. We don't need that to happen. So the CPU will not allow that. Okay, so what the CPU will do right here is say, okay, if the sign is 1, then just duplicate, insert a 1, and this one is gonna come here. The 0 is gonna come here, this one 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 gonna go to the carry flag. So this way we protected the sign. What if the number is positive, but we are doing arithmetic to the right? It's just gonna duplicate it. Okay, just imagine if the number is 40. The number is 40, we just gonna, since this is a 0, we're gonna duplicate it, and everything else is gonna come, is gonna fall apart, okay? And this is gonna go to the carry flag. You see what I'm talking about? So it's gonna duplicate. So if you look at this number, this is F0. If you look at this F0 right here, so the most significant bit is 1, then we have to duplicate it. So this is negative 16. And if you shift it by 1, we know if we shift by 1, we are dividing by 2, right? So if it's negative 16, if you take this number and you choose complement it and you get it into the decimal format, you will know that's negative 16. If you shift it to the right, okay? If you shift it to the right by preserving the sign, now you have a negative 8. Okay, so play with this one. And the most significant bit, the least significant bit now is going to be the sign of the, it's going to be discarded, or it's going to be moved to the carry flag. You see what I'm talking about? So now you have a negative 80. I will give you like a simple idea of what's negative 80 in decimal is. But I know if I shift it to the right, it is going to be divided by 1. So it's going to be dividing by 2. So it's going to be 40. But if I shift it twice to the right, it's going to be negative 10. But I would really like you to think about what is 80, right? What's 80 in binary, because this is not 80 in hex. So if you convert that number, just think about it, how you're going to make an 80, right? So this is something simple we mastered already in the class, right? So you're going to have 1, 2, 4, 8, 16, 32, 64, 128, right? So we need 18, we need 80. So this is going to be 164. So if I have 64 and 32, this is going to be 90. We don't need it. So if you have 64 and 16, this is 10, and this is 8. So this is perfect, right? So this way we have 80. You see it? So this is an 80, right, guys? But we need negative 80. So we have to 2's complement this. So this is going to be 1, 1, 1, 1, 0, 1, 0, 1, and then we need to add a 1. Remember that? So 0 and a 1, 0 and a 1, 0 and a 1, 0 and a 1. This is 1, 1, 0, 1. So this is 80. You need to do that, right? You might see it on the quiz or on the test. So now this is 80, and you can shift this one to the right. So if you're shifting it arithmetically to the right, then you have to duplicate the sign, right? So if you want to do this, do you guys see it so far? Okay, let me see. Okay, so if you do this one right here, then we're going to insert a 1 in here, right? Because we are duplicating the most significant bit. And then this is going to come here. This is here. This is here. This is here. This is here, this is here, this is here, and this is going to go to the carry flag. So this is going to be the result. Okay. So if you get that 140, then you have to, I'm sorry, I did a mistake in here. I know I was doing something not right. So we have to have the 1 right here, remember? Because this one's going to come here. So everything else is correct. So this is now the new value, which is -40. To complement this, you're going to know it's -40. And then you have now to shift this twice, right? So that means that you have to insert what? Twice means you are inserting 2 1s. And this is going to be the other 2 1s in here. They're going to come in here. And then you're going to lose these. So I will write just this number. So it's going to be 0, 1, 1, 0. So this is going to be -10. Okay? So this is exactly what it is. All right, so this is shift arithmetic. All right, so these are some applications. So I would like you to play with this. Just put them in there and try to play with them. It's fun. You need to know how to do shift arithmetic. All right. So with that, we're really done with the shift. So the only thing that I usually have my students confused with is they said, what if I shift a number and I get shifted more than I should? So if you shift a number more than I should, what do you mean by more than you should? Just remember, if you are using a byte, the best you can do is 255, right? 0 to 255. If you try to push or you shift with a number of times that is more than this range, you're going to get an invalid number. And the carry flag is going to show it anyway. Okay? So even for the negative, this is for the unsigned. For the sign, remember, when you look at a number, your number must be within the -1 to -128. So if your number is beyond that, then I don't know what you are doing. So if you're getting something out of that, always look at the amount you're shifting with and the value you're shifting. Let's say if you have a -128, right, guys? So if you have -128. So -128 is going to be what? It's going to be 1, 0, 0, 0. You agree, guys? So this is -128. You agree? So this is 1, 2, 4, 8, 16, 32, 64, 128. So we know that this is a sign. So it's arithmetic shift. I'm talking about the arithmetic shift. So if you want to shift this one where? If you want to shift this one to the left. So can you do that? Okay, if you shift this one to the left, then the carry flag is going to be 1 and everything else is going to be 0, right? So that means you are not getting anywhere because you are exceeding the space. So shifting to the left means multiplying, right? If you multiply this number, you're going to get a larger number, but the space cannot take a larger number, negative number. That is the largest negative number. Do you see what I'm talking about? Okay, so let's say even if you have maybe negative, let's just assume that whatever this number is, let's say -80. So if you multiply -80 by 2, you're going to get what? 160, right? Do you have 160 in here? No. So you're going to get a garbage. You're not going to get a meaningful number. All right. So the best you can do is -64, right? If you shifted 1, so you're going to get -28, 128. That makes sense. But after that, you can do nothing. Okay. I mean, what I mean, you can do nothing. I mean, you cannot get a meaningful result. Okay. So now we're going to move into another interesting arithmetic instruction. So now we know shift to the left, shift to the right. Logically, it's like multiplying or dividing, right? And shifting to the right or to the left arithmetically we're going to get divide and multiply, but we have to consider the sign, right? So now we're going to look into the rotation. It is very interesting to know the rotation, just in case if you encounter this in your in any time in your career. So the rotations are very important instructions. All right. So the whole idea, as you can see right here, you take the, if you want to rotate to the left, so you take the most significant bit right here, okay, and then you're gonna rotate it, so there is nothing is gonna be lost, okay. So before you do this, you just need to copy this to the carry flag and then take this value, put it there. So that's gonna rotate everything around, so we are not losing anything. But remember, before we rotate, we copy the most significant bit if we want to rotate to the left, okay. So if you look at this number right here, and if we want to rotate it by 1, then we're going to take this number, we're going to copy this to the carry flag. That's why you see that it must be the value of the carry flag, right? And then we're going to do what? We're going to take this value and put it there. If we put this value there, then we're going to have 1, and then we're going to have this 0, 0, 0, 0, 1, 1, 1. That's it, because this one has already been rotated. So we did a rotation in here without losing anything. We just rotate. Okay, this is important in multiple, it has multiple applications, but we just want to understand. So this is how rotation works, okay? And this is going to be, let's say, this is an example too, right? So if you want to rotate by 1 right here, and you have 40, isn't that 40? So you're just going to copy this to the carry flag. So the carry flag is going to be 0. And then you're going to take this 0 here. If you take this 0 here, then this one now becomes the most significant bit. Do you see it? So that's the value. If you want to rotate it again, then you copy this to the carry flag, and you take this value right here, and then now your most significant bit is going to be 0. You take this one right here, and then now your most significant bit again is going to be 0. So when you take this one to the most right or to the least significant bit, you have to copy it to the carry flag. So this is how the rotation works. Okay, you can do multiple rotation as well. So if you have this 3 right here and you want to do it 3 times, so this is going to be the first copy to the carry flag, we put it there. Second copy to the carry flag, we put it there. Third copy to the carry flag, so the carry flag now is 1, right? And we put it there. So this is exactly what you're going to see, okay? So what you're going to see right here, this is going to be the rotation. You see it, guys? You see what I'm talking about? So this one, the first time you do it, the 0 is going to come here, right? It's going to come somewhere. Let me show you here. So if you have this 0, 0, 1, 0, 0, 0, 0, right? 1, 2, 3, 4, 1, 2, 3, 4, right? So the first time we're going to get this 0 here. So the 0 gone, right? And then the second and carry flag now is 0 because we copy it. Then we're going to get this 0 here. So this 0 gone, and then the second value is going to be 0 here. You see what I'm talking about? Okay, so for the third time, this is going to go to the carry flag. We copy it first, and then it's going to come here. So this one gone. So this is now my new value. Okay, so this is the rotation, and this is when we rotate to the left. Okay, clear? This is 26. If you want to reverse it, how many times do you need to do it? 4 times, right? Right, guys? So if you want to look at the 6 right here, just do it in binary always. These are like bit manipulation. So if you have 6, this is 6, right, guys? And this is what? This is 2. So if you do this 4 times, you get this here, and then you get this here, and then you get this here, and then you get this there 4 times. So now I'm having 6, 2. So it's 26. Okay? If this is 62, but in your case, it's 26. If you have the 2 here, you do it the other way around. Okay? So this is basically what the rotation to the left is. Okay? And then to the right is going to be exactly the same, but you copy now the least significant bit to the carry, and you insert the 0 from the left because you want to move to the right, right? So it's going to be identical. Okay? These are like a couple of examples for you to play with, but the basic idea is just to do the rotation. So right here in this example, you have 3, right, guys? So this is 3, and this is F, right, guys? And you want to rotate this 3 times, right? So you have to keep in mind, like, this is your carry flag. So you want to do this rotation to the right, right? So to the right means we have to take this here. So we're going to move it where? We're going to move it to the right. When we do it to the left, we take this one here. We're going to move to the left. So now we're going to do it to the right. So first, we're going to copy the carry flag first time 1, right? And then now, we're going to get this one right here. You with me? And then the second time, we're going to copy this one. So the carry flag now is 1. And this one is going to go right here. You still see it? And then the third time, we're going to take this one, copy right here, and this one is going to go right here. So this is now my new value. 1, 2, 3, 4, I'm sorry. And then 1, 2, 3, 4. Run it in Visual Studio, you will see it, and keep your eye on the flags, okay, when you do that one. Okay, when you do it multiple times, that's what I was talking about right here. So just keep your eye on what is the last value that you should assign to the carry flag. Okay, these are multiple applications. Please play with them. They're very important for your quizzes. All right. So here we have another special kind of rotations. So here we say rotation with the carry to the left. So instead of taking this value to rotate to the left or to rotate to the right, you're just going to go to the default value in the carry and use it to do the rotation. This has very specific application, especially in integer arithmetic, but let's just first learn the mechanics. So instead, now if you want to shift something to the left by using the carry, instead of taking this one, copying it here, and then inserted it from that side, no, just go to the carry flag right away and use the carry flag value to the rotation. So when you do the rotation, the most significant bit automatically is going to go to the carry flag. Okay? So if you need to decide what should be the carry flag value, you can use this instruction, CLC. Okay, so that's what you see in the top. CLC means what? Clear the carry flag. So if the carry flag somehow is 1, it's going to become 0. If it's 0, it's going to remain 0. But you want to make sure that I'm rotating when the carry flag is 0. Just set it up. And then the rest is just normal rotation. Do you see what I'm talking about? So the same happens for when you want to rotate to the right, but right here, for some reason, you can do CLC or you can do STC. And you know, this is a single instruction that has no operands, explicit, but we know it has implicit operands, right, guys? So the implicit operands is what? Can you think about it? So the implicit operand, it's going to be what? The destination, it means the E flag. And in particular, the carry flag bit is going to go automatically there and set it or clear it. And the rest is going to be a normal rotation. All right, but instead of copying this value now, we just copy the carry flag first. Okay, again, these are applications. They are very important for you to play with. If I were you, I would just like run my Visual Studio and play with them. All right, so there are also a couple of advanced shift arithmetic instructions like CHL and CHF. This is what we call double precision. These are heavily used in image processing and image rotations. We are not going to focus on them right here. What I want you to take away is like how to use shift. That's what is really very important. How shift is applied to do fast multiplication and division. And you should think about, or you should differentiate between shifting to the left and shifting to the right. And when you say shifting to the right, it's going to be sensitive if I'm doing arithmetic shifting, or it doesn't make any sense, or it has no meaning if we are logically shifting things around. Okay, guys? Okay. So with that, we're going to stop right here. Just take some break, and tomorrow, day after tomorrow, Wednesday, we're going to continue on multiplication and division instructions. But I just want to motivate you that when we do the multiplications, we're going to learn multiplication in terms of sign integer and unsigned integer and sign integer. We're going to do division, unsigned division and sign division. And we're going to see how these instructions are important. The good idea about multiplication and division instructions in x86, they will really teach you how the CPU does the multiplication and division. If in your ARM Raspberry Pi, we are using ARM, the multiplication is straightforward. It's like a high-level Java multiplication. But right here, it's going to force you to come down to the architecture. And it's going to be a lot of fun, okay? So we're going to cover that in the on the next class. And for now, I just hope you guys enjoyed it. And I will upload the video right now. Just leave your questions, audio or text, and I will try my best to get back to you. Thank you.